Hello, and welcome to ZzZscience. Wherever and whenever you're listening from, I hope you're doing well. Take a moment to get comfortable. There's nothing you need to focus on. Nothing you need to stay awake for. Just let your body relax and let your mind slow down. If you feel like it, you can tell me in the comments where you're listening from. And if there's a science topic you'd like to gently fall asleep to, I'd love to hear it. For now, let's slow things down and begin. The universe stretches outward in every direction. Billions of galaxies, trillions of stars, planets beyond counting. And yet, when we listen, we hear nothing. Not silence in the way a quiet room is silent. Not the absence of sound because sound needs air to travel. But silence in the sense that no signal reaches us. No pattern in the radio waves. No deliberate message in the light. Nothing that suggests we are not alone. This silence has a name in science, the Fermi paradox. Named after physicist Enrico Fermi, who asked a simple question during lunch with colleagues in 1950. If the universe is so vast and so old, where is everybody? The question assumes that life should be common, that intelligence should emerge often enough that at least some civilizations would become visible across space, that we should see signs of technology, expansion, communication. But we don't. The paradox isn't really about silence itself. It's about the gap between expectation and observation, between what seems likely and what we actually find. Let's begin with distance. Space is not empty in the way we imagine emptiness. It contains matter, radiation, magnetic fields, particles moving at incredible speeds. But between objects, the gaps are enormous. Not just large. Enormous in a way that resists human comprehension. The nearest star to our Sun is Proxima Centauri. It sits 4.24 light-years away. That means light, traveling at 300,000 kilometers per second, takes more than 4 years to cross that gap. Light does not slow down. It does not tire. It moves at the fastest speed possible in our universe. And still, it takes 4 years. If we sent a radio signal to Proxima Centauri today, and if someone there received it and immediately sent a reply, we would wait nearly 9 years for that conversation to complete one exchange. One question, one answer. 9 years. But Proxima Centauri is close. Unusually close. Most stars in our galaxy are thousands of light-years away. Many are tens of thousands of light-years distant. The galaxy itself spans roughly 100,000 light-years from edge to edge. A signal sent from the far side of the galaxy would take 100,000 years to reach us. If it was sent during the time humans first began migrating out of Africa, it would only now be arriving. Distance does not just delay communication, it transforms it. By the time a signal crosses such distances, the civilization that sent it may no longer exist. The star it orbited may have changed. The language, the technology, the entire context of the message could be lost to time. And this assumes the signal is sent in our direction. Space expands in 3 dimensions. A signal broadcast outward spreads across an ever-growing sphere. The farther it travels, the more its energy disperses, like ripples on a pond, but in all directions at once. By the time a signal reaches another star system, it may be so faint that it blends into the background radiation of space itself, undetectable, indistinguishable from noise. We often imagine that advanced civilizations would broadcast powerful signals, that they would want to be found. But power requires energy. Energy requires resources. And broadcasting in all directions, continuously, at strength sufficient to cross interstellar space, would demand an enormous expenditure. It may be more efficient to remain silent, to listen rather than transmit, to conserve energy for other purposes. If most civilizations make this same calculation, the galaxy could be filled with listeners, all waiting, all silent, none transmitting. This is sometimes called the SETI assumption problem. SETI, the search for extraterrestrial intelligence, operates on the idea that civilizations will broadcast. But that idea may reflect human behavior more than universal behavior. Humans broadcast because we developed radio technology in a specific way, at a specific time, without awareness of others listening. We sent signals into space unintentionally for decades. Television broadcasts, radar signals, military communications, all of it leaked into space as a byproduct of our activities. But that leakage is temporary. As our technology improves, we use more focused transmissions. Fiber optics instead of radio towers, narrow beams instead of wide broadcasts, encrypted signals that look like noise to an outside observer. Within a century or two of developing radio, a civilization might become nearly silent again, not because they stopped communicating, but because their communications became efficient, contained, invisible from the outside. If this pattern is common, then the window during which a civilization is detectable might be very brief. 100 years, maybe 200. A tiny sliver of time in the lifespan of a star. If two civilizations exist in the same galaxy, but their detectable periods don't overlap, they will never find each other, even if they are only a few thousand light-years apart. Time operates differently across the universe, not in the relativistic sense, though that matters too, but in the sense that events are not synchronized. There is no universal clock, no shared now. When we look at a star 1,000 light-years away, we see it as it was 1,000 years ago. The light reaching our eyes left that star during the Middle Ages on Earth. If a planet orbits that star, and if someone there is looking back at us, they see Earth as it was 1,000 years ago, before telescopes, before electricity, before any sign that we might someday reach into space. The universe we observe is a patchwork of different moments. Each point of light represents a different time. The farther we look, the deeper into the past we see. If a civilization existed 10,000 years ago and left behind structures, signals, or other traces, we would only now be seeing them if they were 10,000 light-years away. If they were farther, we're still waiting. If they were closer, we've already missed it, unless the signal or structure is still present. This creates a kind of cosmic hide-and-seek, not intentional, not designed, but a natural consequence of the speed of light and the immensity of time. Consider how brief our own detectable period has been. Radio technology emerged around 1900. That's 125 years ago. Our signals have traveled 125 light-years into space. Any civilization farther than that has not yet seen evidence of us. To them, Earth is still a quiet planet. No radio, no television, no indication of technology. And within that 125 light-year bubble, there are only a few thousand stars. Not millions, not billions, a few thousand. Most of them without planets we've confirmed. Most of those planets, if they exist, unlikely to host life. And of the few that might, almost none likely to have intelligent life. The odds of overlap in both space and time become vanishingly small. Even if we assume life is common, intelligence is another threshold. Life on Earth existed for more than 3 billion years before anything resembling intelligence emerged. Single-celled organisms dominated the planet for the vast majority of Earth's history. Multicellular life is relatively recent. Complex animals more recent still. Humans, with technology, represent a tiny fraction of a percent of Earth's biological timeline. If this pattern holds elsewhere, then most life in the universe is microbial. Algae on distant moons, bacteria in subsurface oceans. Simple, resilient, invisible from space. Intelligence may be rare not because it's impossible, but because it's not necessary. Evolution does not favor complexity for its own sake. It favors survival. And simplicity often survives better than complexity. A bacterium can endure extreme heat, cold, radiation, and pressure. It can lie dormant for thousands of years. It requires minimal resources. It adapts quickly. In many environments, intelligence would be a disadvantage. Too costly, too fragile, too slow to reproduce. Even if intelligence does emerge, technology is not guaranteed. Dolphins are intelligent. Crows are intelligent. Octopuses are intelligent. None of them build radios. Technology requires not just intelligence, but a specific kind of intelligence. One that manipulates the environment, that uses tools, that builds on previous generations' knowledge, that develops language complex enough to transmit abstract ideas. It also requires the right environment, hands, or something like hands, to manipulate objects. Fire, or some other energy source. Smelt metals and create complex tools. A stable climate that allows long-term planning. Social structures that enable cooperation and specialization. Remove any one of these factors, and technology may never develop. Intelligence alone is not enough, and even if technology develops, it may not last. Civilizations collapse, resources deplete. Wars destroy infrastructure, climate shifts, asteroids strike, supervolcanoes erupt. A civilization might reach the brink of interstellar communication, then fall back. Lose the knowledge, start over. On Earth, we've come close to collapse several times. Nuclear weapons, climate change, pandemics. Any of these could set us back centuries, or end us entirely. If collapse is common, then the galaxy might be filled with ruins, dead worlds, silent monuments to civilizations that rose and fell. We wouldn't see them unless we visited. And visiting requires crossing distances we can barely imagine. The fastest spacecraft we've ever built, Voyager 1, travels at about 17 kilometers per second. At that speed, it would take more than 70,000 years to reach Proxima Centauri. And Voyager is not aimed at Proxima Centauri. It's headed in a different direction entirely. It will wander the galaxy for millions of years, never coming close to another star. To cross interstellar space in a human lifetime would require speeds we don't know how to achieve. Velocities that approach the speed of light. Energies that dwarf anything we've ever produced. Shielding against radiation and impacts that would destroy any conventional spacecraft. Even if we solve these problems, the universe may still hide itself through sheer scale. Consider how we search for signals. We point radio telescopes at the sky and listen. But the sky is vast. A radio telescope can only observe a tiny patch at a time. To cover the entire sky, we need thousands of hours of observation time. And even then, we can only listen to certain frequencies. Radio waves span a huge range of frequencies, from a few kilohertz to hundreds of gigahertz. Each frequency requires a different receiver. Each frequency travels differently through space. Some are absorbed by Earth's atmosphere. Some are drowned out by natural sources like pulsars and quasars. We can't listen to every frequency at once. We have to choose. And our choices are based on assumptions. We assume civilizations will use frequencies similar to the ones we use, that they'll broadcast in ways we recognize as artificial, that they'll send signals strong enough to detect across light years. But these assumptions may be wrong. A civilization might communicate using technologies we haven't discovered. Gravitational waves, neutrinos, quantum entanglement, something else entirely. If their signals don't register on our equipment, we would never know they were there. Even within the radio spectrum, we might be looking in the wrong place. Human radio technology favors certain frequencies because they penetrate our atmosphere and travel long distances on Earth. But in space, other frequencies might be more practical. A civilization might choose frequencies we haven't monitored closely, or frequencies we dismissed as too noisy. The universe is not quiet. It hums with radiation. The cosmic microwave background, emissions from stars, galaxies, black holes, charged particles spiraling through magnetic fields. All of this creates noise, static, interference. To detect an artificial signal, we need it to stand out from this background. It needs to be strong or patterned in a way that nature doesn't produce. But patterns can be subtle, and strength diminishes with distance. A signal that seems obvious up close becomes ambiguous at a distance. We might detect something unusual, but be unable to confirm it's artificial. We might dismiss it as a glitch, or a natural phenomenon we don't fully understand yet. This has happened before. In 1967, astronomers detected a strange, pulsing radio signal. It repeated with such precise timing that they briefly considered it might be artificial. They called it LGM-1, Little Green Men 1. But further observations revealed it was a pulsar, a rotating neutron star, entirely natural. Fast radio bursts are another example. Brief, intense flashes of radio energy from distant galaxies. When they were first discovered, their origin was unknown. Some speculated they might be artificial, but over time, evidence pointed toward natural sources. Magnetars, colliding neutron stars, extreme astrophysical events. Nature produces patterns, repetition, complexity. Things that look, at first glance, like they might be designed. This makes the search for artificial signals difficult. We need overwhelming evidence before we can claim a detection. And overwhelming evidence is hard to obtain from light years away. Even if we detected an unambiguous signal, decoding it would be another challenge entirely. We have no common language with an alien civilization. No shared references. No context. Imagine receiving a message in a completely unknown language. No translation guide, no pictures, no sounds you recognize. Just a stream of symbols or numbers. You might determine it's artificial, that it contains information. But extracting meaning could take years, decades, maybe longer. And if the message is millions of years old, the civilization that sent it might not exist anymore. We would be decoding the words of ghosts. Some scientists have proposed that messages might be sent using mathematics. The assumption is that mathematics is universal, that any technological civilization would understand prime numbers or pi or basic geometry. But even mathematics requires context. The base we use to represent numbers, the symbols we use for operations, the concepts we consider fundamental. These are cultural choices, shaped by our history and biology. A civilization with a different sensory system might develop mathematics differently. One that thinks in 3 dimensions instead of 2, or one that perceives time differently. Their mathematics might be correct and functional and entirely alien to us. Communication across the stars may be possible, but it may also be so difficult and so slow that it's impractical, not worth the effort. If you knew a conversation would take thousands of years, would you start it? If you knew the other side might not understand you or might misunderstand you in dangerous ways, would you risk it? Silence might be a form of caution. Not hiding, just waiting, observing, listening carefully before speaking. There's another layer to consider, the idea that visibility equals vulnerability. Broadcasting into space announces your presence. It tells anyone listening where you are, what frequencies you use, potentially what your technology looks like, what your biology might require. For a young civilization, this might be dangerous. If the universe contains civilizations that are not friendly, or that view others as resources, advertising your existence could be a mistake. This is the dark forest hypothesis, named after a science fiction novel, but taken seriously by some scientists. The idea is that the universe is like a dark forest. Every civilization is a hunter, moving quietly, listening for others. The first to make noise is the first to be found, and being found might mean being destroyed. It's a bleak scenario, and it's speculative. We have no evidence that hostile civilizations exist, but we also have no evidence they don't. In the absence of data, caution might be rational. Even without hostility, contact could be risky. A more advanced civilization might overwhelm a less advanced one. Not through violence, but through culture, technology, ideas. The less advanced civilization might lose its autonomy, its identity, its ability to develop independently. This has happened on Earth. When technologically advanced societies contacted isolated ones, the results were often devastating. Not always through conquest, sometimes through disease, economic disruption, cultural erosion. If this pattern holds at a cosmic scale, then civilizations might avoid contact deliberately. Not out of fear, but out of respect. A kind of cosmic quarantine. Let each civilization develop on its own. Don't interfere. Don't influence. Just observe from a distance. This is the zoo hypothesis. The idea that advanced civilizations know we're here, but choose not to interact. They watch us the way we watch animals in a nature preserve, from a distance, without intervention. It's another speculative idea. We have no way to test it. But it offers an explanation for silence that doesn't require civilizations to be rare or extinct. Just quiet, deliberate, patient. Patience on a cosmic scale is different from human patience. We think in terms of years, decades at most. But the universe thinks in terms of billions of years. A civilization that has existed for 1,000,000 years might view time very differently than we do. They might not feel urgency. They might be content to wait, to observe, to let things unfold naturally. If most long-lived civilizations develop this perspective, then the galaxy might be full of watchers, all silent, all waiting, none in a hurry to make contact. From our perspective, this looks like emptiness, but it might be something else, a different kind of presence, one that doesn't announce itself. There's also the possibility that we're simply looking in the wrong way, that the universe isn't hiding, we're just not seeing. Human perception is limited. We see a narrow slice of the electromagnetic spectrum, hear a narrow range of sounds. Our instruments extend our senses, but they still have limits. We build detectors based on what we know, what we expect, what our theories predict. But if there's something outside those theories, we might not have the tools to detect it. This has happened before in science. Dark matter was invisible for decades because we didn't know what to look for. We detected its gravitational effects, but couldn't observe it directly. We still can't. We know it's there because of how it affects galaxies, but the particles themselves remain elusive. If civilizations use technologies based on principles we haven't discovered, they could be all around us and we wouldn't know. Not because they're hiding, but because we don't have eyes for that kind of light. This isn't mystical thinking. It's a recognition of human limitations. Our knowledge is incomplete. Our tools are imperfect. The universe contains phenomena we haven't encountered yet. A few hundred years ago, radio waves were unknown. X-rays were unknown. Nuclear energy was unknown. We couldn't have detected them even if they were everywhere. We lacked the concepts, the instruments, the understanding. We're likely in a similar position today with respect to phenomena we haven't discovered. There are things we don't know. Gaps in our knowledge we can't see because we don't know where to look. Another consideration is energy efficiency. Advanced civilizations might use very little energy, not because they're primitive, but because they're efficient. Early human technology was wasteful. Steam engines, incandescent bulbs, combustion engines. All of them converted only a small fraction of energy into useful work. The rest became heat, noise, waste. As technology improves, efficiency improves. LED bulbs use a fraction of the power of incandescent bulbs. Electric motors are more efficient than combustion engines. Computers use less power per calculation every year. If this trend continues, an advanced civilization might operate on surprisingly little energy. They might recycle everything, use fusion or antimatter or some other highly efficient power source. Minimize waste, minimize emissions. From the outside, they would be faint, hard to detect, not because they're trying to hide, but because they're not wasteful. We assume advanced civilizations would be visible because we imagine them doing large-scale engineering, building megastructures, Dyson spheres that capture the entire output of a star, ring worlds, artificial planets. But these ideas come from mid-20th century science fiction. They assume civilizations will always want more energy, more space, more resources. That assumption might be wrong. Growth might not be endless. A civilization might reach a stable state, a balance between needs and resources. They might prioritize quality over quantity, sustainability over expansion. If so, they would be small, contained, efficient, and very difficult to detect from light years away. There's also the question of what we mean by civilization. We imagine cities, governments, economies, technologies, but these are human constructs, shaped by human biology and history. An intelligent species with a different biology might organize differently, might not build cities, might not use metal, might not need technology as we understand it. Dolphins are intelligent, but they don't build. Octopuses are intelligent, but they're solitary. If intelligence evolves in the ocean, on a world without fire or solid ground, what does civilization look like? It might look like nothing we'd recognize. No radio signals, no structures, no visible signs, just organized behavior. Communication, culture, things we could only detect if we were there, up close, observing directly. The universe might be full of such civilizations, intelligent, complex, but invisible from space because their way of being doesn't produce the signals we're looking for. We search for ourselves, for reflections of human civilization, radio, infrared signatures from industrial heat, atmospheric pollutants, optical signals. All of these assume others will be like us. But life on Earth took billions of years to produce humans, and humans are one branch on a vast tree of life. Most of that tree doesn't use technology, doesn't build, doesn't communicate across distances. If we're an unusual branch, then looking for others like us might be looking for a rare outcome. Not impossible, but uncommon enough that the distances between similar civilizations are vast. Time becomes important again here. Not just the time it takes for signals to travel, but the time it takes for intelligence to evolve, for technology to develop, for a civilization to become visible. If the average time from the formation of a planet to the emergence of a technological civilization is several billion years, then most planets in the universe are still waiting. Life might be there, even complex life, but not intelligence, not yet. Earth formed 4.5 billion years ago. Life emerged relatively quickly, within a few 100 million years. But intelligence took much longer, 3.5 billion years. Most of Earth's history was microbial. If this is typical, then the galaxy is young in a biological sense. Stars are forming, planets are forming, life is starting. But most of it hasn't reached the stage where it can be detected from afar. We might be early, one of the first, not the only one, but among the first wave of civilizations to develop technology. If that's true, then the silence makes sense. We're listening, but there's not much to hear yet. Give it another billion years, another few billion. The galaxy might become much noisier. But a billion years is incomprehensible to us. Humans have existed for a few 100,000 years, civilization for a few thousand, writing for 5,000. We don't think in terms of billions. The universe does. Stars live for billions of years. Galaxies evolve over billions of years. The processes that create life, intelligence, and technology operate on these timescales. From that perspective, the current silence is just a moment, a brief pause, not permanent, not strange, just the way things are right now. There's a tendency in humans to see patterns, to interpret silence as absence, emptiness as loneliness. But silence can be fullness. Absence can be presence not yet revealed. When we look at the night sky, we see stars. Thousands of them, if we're far from city lights. But those thousands are a tiny fraction of what's out there. Most of the universe is beyond our sight, hidden by distance, by dust, by the limits of our eyes. Telescopes reveal more, billions of galaxies, each containing billions of stars. The numbers become abstract, too large to feel, too large to comprehend. And yet each of those stars is a place, a location, a point where matter gathers and energy flows. Many of them have planets. Some of those planets have conditions that could support life. Some might have life. A few might have intelligence. But we can't see them directly. Not yet. Our telescopes can detect planets by watching stars dim as planets pass in front, or by measuring the wobble of a star as a planet's gravity tugs on it. Indirect methods, clever, but limited. We can analyze the light that passes through a planet's atmosphere, look for chemicals, water vapor, oxygen, methane. Combinations that might indicate life, but these are hints, not proof. Oxygen can be produced by non-biological processes. Methane can come from volcanoes. We need more data, better instruments, more time. And even if we find strong evidence of life, we still won't know if it's intelligent, if it's technological, if it's trying to communicate. We would just know we're not alone, that life exists elsewhere, which would be an answer, not to the question of silence, but to the question of whether life is rare. The silence might remain even if life is common, because most life doesn't broadcast, doesn't build, doesn't reach into space. It simply exists, grows, evolves, adapts, lives and dies on the surface of a world we'll never visit. There's a kind of humility in this, an acknowledgement that the universe doesn't owe us answers, that it doesn't exist for our curiosity. It simply is, and we are part of it, trying to understand, trying to see. We've been searching for less than a century. That's a blink, a moment. In cosmic terms, we've barely started. Radio astronomy began in the 1930s. SETI, as an organized effort, started in 1960. That's 65 years. In that time, we've surveyed a small fraction of the sky, listened to a small fraction of possible frequencies, analyzed a small fraction of nearby stars. It's not that we've found nothing. We've found pulsars, quasars, fast radio bursts. All natural, all fascinating, all expanding our understanding of the universe. But nothing artificial. Nothing that suggests intelligence beyond Earth. Some interpret this as evidence that we're alone. That intelligence is so rare or so brief that we might be the only one in the galaxy right now. Maybe in the observable universe. Others interpret it as evidence that we haven't looked hard enough, that the search has only just begun, that absence of evidence is not evidence of absence. Both perspectives are reasonable. We don't have enough data to decide. The sample size is too small, the search too limited, the time too brief. What we can say is that if intelligence is common, it's not obvious. It's not loud. It's not broadcasting in ways we can easily detect. It's either rare or quiet, or hidden by distance and time, or using methods we don't recognize. Any of these could be true, or all of them, or something else we haven't considered. The universe doesn't present itself simply. It requires effort to understand, patience, careful observation, willingness to admit uncertainty. When we ask why the universe seems to hide itself, we're asking why it doesn't conform to our expectations, why it doesn't make things easy for us, why it doesn't announce its contents clearly. But the universe has no obligation to be easy. It's not designed for our convenience. It exists according to physical laws, processes, forces, things that operate whether we're here or not. Our expectations come from our experience, from living on a planet where life is abundant, where communication is common, where we're surrounded by signals and sounds and signs of other minds. We expect the universe to be similar, but it's not a planet. It's not a place. It's a collection of places, separated by distances so large that they change the meaning of proximity. On Earth, separation is measured in kilometers, thousands of kilometers at most. Signals cross those distances in fractions of a second. We take it for granted. We expect connection to be easy, instantaneous. In space, separation is measured in light years. Signals take years, centuries, millennia. Connection is not easy. It's not instantaneous. It requires patience we're not used to exercising. This changes the nature of community. On Earth, Communities form because individuals can interact frequently, share information, coordinate, build relationships over time. In space, interaction is so slow that communities in the human sense might not form. Civilizations might be aware of each other, but unable to interact meaningfully. Too far apart, too delayed. A message sent today won't receive a reply for thousands of years. By the time the reply arrives, the original sender might be gone. The civilization might have changed. The question might be irrelevant. This creates a kind of isolation, not by choice, not by hostility, just by the nature of space itself. We feel this isolation when we look at the sky. We see stars. We know they're suns. We know some have planets. We know some of those planets might have life. But we can't reach them, can't talk to them, can't confirm what we suspect. So we search, we listen, we hope, and we accept that the answers might not come in our lifetimes, or in the lifetimes of our children, or their children. The search is long, the universe is vast, and silence is not emptiness. It's just the sound of distance. There's another dimension to consider, the idea that silence might be natural, that noise is the exception. On Earth, we're surrounded by sound. Animals call, wind blows, water flows. Humans talk, sing, shout. We assume sound is normal. Silence is absence. But in space, silence is the default. Sound requires a medium, air, water, something for waves to travel through. Space is a vacuum. Sound doesn't travel. Only light. Only radiation. Even on planets, noise is temporary. A storm passes. Animals quiet at night. Over long timescales, most places are silent most of the time. If civilizations follow this pattern, they might be noisy briefly, then quiet. Not because they disappear, but because noise is not a permanent state. It's a phase. Young civilizations might be loud, broadcasting unintentionally, using inefficient technologies. But as they mature, they quiet down, become more deliberate, more contained. If we're in our loud phase, and others have passed through theirs, we might be shouting into a galaxy that has learned to whisper. Whispering is harder to hear, especially across light years, especially against the background hum of the universe. We might need better ears, better instruments, better understanding of what we're listening for. Or we might need to accept that some things can't be heard from far away, that closeness is required, that to know if someone is there, we might need to go there ourselves. Which brings us back to distance and time, and the challenge of crossing the gaps between stars. We dream of faster travel, warp drives, wormholes, technologies that bend the rules of physics to make the impossible possible. But dreams are not plans, and physics has limits we can't simply wish away. The speed of light is not just a speed limit. It's a fundamental property of space-time. To go faster would require exotic matter, negative energy, things we've never seen, things that might not exist. Even if they do exist, harnessing them is another challenge, one that might take centuries to solve, or millennia, or might never be solved. So, we're left with slow travel, generation ships that take thousands of years to reach nearby stars, or hibernation, or sending robots instead of people, or not going at all, just listening, watching, imagining. Each approach has trade-offs. Generation ships require enormous resources, stable ecosystems, social structures that can last centuries without outside contact. It's possible, but difficult. Hibernation requires technologies we don't have, ways to preserve human bodies for decades or centuries without damage, ways to wake up safely, ways to ensure the ship continues functioning while everyone sleeps. Robots are easier in some ways. They don't need food, don't age, don't get bored, but they also don't experience, don't wonder, don't feel the significance of arriving at a new world. And not going means accepting that some questions will remain unanswered, that we will wonder but never know, that the universe will keep its secrets. This is hard for humans. We're curious. We want answers. We want to see, to touch, to confirm. But maybe the universe is teaching us patience, humility, acceptance of limits. Not every question has an answer we can reach. Not every mystery can be solved. Some things are simply too far, too old, too different. And that's okay. It doesn't diminish the value of asking, of searching, of trying to understand. The search itself is meaningful. It expands our knowledge, our capabilities, our perspective. It reminds us that we're part of something larger, that Earth is one world among countless others, that our stories are not the only stories. Even if we never find another civilization, the search teaches us about the universe, about how stars form, how planets evolve, how life emerges, how intelligence develops. These are questions worth asking, whether or not we find others asking them too. And maybe, in time, we'll develop new ways to search, new instruments, new ideas, new understanding of what signals might look like, how they might travel, where they might come from. Science improves, technology advances. What seems impossible today might be routine tomorrow, or in 100 years, or 1,000. The universe is patient. It's been here for nearly 14 billion years. It will be here for billions more. It's not in a hurry. Neither should we be. The search is not a race. It's an exploration. And explorations take time. We've learned so much already about stars, about galaxies, about the structure of the universe, about the laws that govern matter and energy, about time and space and gravity. Each discovery reveals new questions, deeper mysteries, things we didn't know. This is how understanding grows, not in straight lines, but in spirals. Each loop brings us back to familiar questions, but from a different angle, with new tools, new perspectives. The question of why the universe seems silent is like this. We've asked it for decades. Each time we ask, we learn more. Not always the answer we wanted, but something valuable. We've learned that space is larger than we imagined, that time operates on scales that dwarf human experience, that life requires specific conditions, that intelligence is not inevitable, that technology is fragile. We've learned that our expectations shape what we see, that our assumptions might be wrong, that the universe doesn't have to be the way we think it should be. These are humbling lessons, but important ones. They remind us that we're still learning, still growing, still at the beginning of understanding. The silence of the universe is not a failure. It's not a disappointment. It's a fact, a piece of data, something to think about, to learn from, to integrate into our understanding. It tells us that if there are others, they're not obvious. They're not waiting for us. They're not making themselves easy to find. Maybe they can't. Maybe they don't want to. Maybe they're not there. Maybe they are, but in ways we can't detect yet. All of these are possible. None of them mean we should stop looking, stop wondering, Stop trying to understand. Because the search is not really about finding aliens. It's about understanding our place, our context, our significance. Are we alone? Are we common? Are we early? Are we late? Are we rare? Are we typical? These questions shape how we see ourselves, how we value our existence, how we think about our future. If we're alone, then life is precious, rare, something to protect, something to preserve. Because if it ends here, it might end everywhere. If we're not alone, then life is resilient, common, something that emerges wherever conditions allow, and intelligence might be part of that emergence. Rare, perhaps, but not unique. Both possibilities are profound. Both change how we think about meaning, about responsibility, about the future. And we don't know yet which is true. We're suspended between possibilities, between loneliness and connection, between uniqueness and commonality. This uncertainty is uncomfortable. Humans prefer answers, closure, knowing. But the universe doesn't always provide these things on our timeline. So we wait. And while we wait, we search. Not frantically, not desperately, but steadily, carefully, with the understanding that the answer might not come soon. There's something peaceful in this, in accepting that some questions take time, that rushing won't help, that patience is not passive, it's active, deliberate, intentional. We continue to build better telescopes, better receivers, better algorithms to process the enormous amounts of data we collect. Each improvement brings us closer to an answer. Not necessarily the answer we want, but an answer nonetheless. The James Webb Space Telescope looks deeper into space than any telescope before it. It sees galaxies as they were billions of years ago, watches stars being born, studies the atmospheres of distant planets. Each observation adds to our understanding. We're learning what's normal in the universe, what's rare, what conditions produce what outcomes. This knowledge helps us refine our search, helps us understand where to look, what to look for. We're also learning about ourselves, about how life works, how evolution operates, how intelligence emerges, how technology develops, how civilizations change over time. Earth is our only example, our only data point, but it's a rich one. Life here has existed in countless forms, adapted to extreme environments, survived mass extinctions, evolved complexity despite odds that seem impossibly small. If life here is any indication, life is tenacious, stubborn, creative. It finds ways to survive, to persist, to fill every available niche. But tenacity doesn't mean visibility. Most life on Earth would be invisible from space. You could observe Earth from another star system and miss most of what makes it remarkable. The bacteria, the fungi, the microscopic organisms that outnumber all visible life combined. You might detect oxygen in the atmosphere. That would be a clue. Oxygen is reactive. It doesn't stay free in the atmosphere without something constantly replenishing it. On Earth, that something is photosynthesis. Plants, algae, cyanobacteria. But even that's not certain. An alien observer would need to rule out non-biological sources, photodissociation of water, volcanic outgassing, other chemical processes. It would take careful analysis, multiple observations, time. And even after confirming life, they still wouldn't know about cities, about technology, about radio waves. Not unless they looked very carefully, at the right frequencies, at the right time, with instruments sensitive enough to pick out artificial signals from the natural background. We're trying to do the same thing, looking at other worlds, analyzing their light, searching for clues. It's slow work, difficult, uncertain. But it's possible, and that possibility keeps us searching. There's also the question of what we would do if we found something, how we would respond, how we would interpret a signal from another civilization. We have protocols, plans, ideas about how to verify a detection, how to avoid false alarms, how to share the information, who to tell first. But these are just frameworks. The reality would be complicated, messy, uncertain. A signal from space would raise as many questions as it answered. Where did it come from? When was it sent? Is the civilization still there? What are they trying to say? Should we respond? What would we say? These questions don't have obvious answers. They require thought, discussion, careful consideration of consequences. A response would take years to reach the source, maybe centuries. By the time it arrived, everything might have changed. The signal might have been a lone transmission, a brief experiment, a message in a bottle that the sender never expected to be answered. Or it might be the first contact in an ongoing conversation, one that spans millennia, that involves generations of humans, that changes our civilization in ways we can't predict. Both scenarios are daunting. Both require us to think beyond our immediate experience, beyond our lifetimes, beyond the concerns of today. This is hard. We're not built for thinking on these timescales. Our brains evolved to handle immediate problems, threats we can see, opportunities we can grasp, plans that unfold over days or months or years. Thinking in terms of centuries requires discipline, abstract reasoning, a willingness to care about things we'll never see resolved. But it's not impossible. We do it already in small ways. We plant trees that won't mature in our lifetimes. We build structures meant to last generations. We create art and knowledge for people we'll never meet. Searching for life beyond Earth is an extension of this, a project that spans generations, a question we're asking on behalf of everyone who comes after us. We might never know the answer, but they might. And our searching makes that possible. There's a kind of hope in this. Not the bright, immediate hope of finding something tomorrow, but a quieter hope, a longer hope, the kind that sustains itself through uncertainty. We hope that the universe is full of life, that we're not alone, that somewhere, somehow, others are looking up at their sky and wondering the same things. But even if that hope is never confirmed, the act of hoping is meaningful. It connects us to something larger than ourselves. It reminds us that we're part of a universe that's still revealing itself, still surprising us, still teaching us. The silence doesn't diminish this. If anything, it deepens it, because silence leaves room for possibility, for imagination, for wonder. If the universe were loud, if signals came easily, if contact was simple, it would be less mysterious, less vast, less humbling. The silence preserves the mystery. It keeps the questions open. It reminds us how much we don't know. And not knowing is not failure. It's the condition of being alive, of being curious, of being human. We live in a universe that's mostly dark, mostly empty, mostly silent. This is not a flaw. It's not a mistake. It's just how things are. The darkness is punctuated by stars. The emptiness is structured by gravity. The silence is broken by the light of distant galaxies, by the hum of cosmic radiation, by the faint whisper of the Big Bang itself, still echoing through space after nearly 14 billion years. These are the sounds of the universe, not voices, not messages, just the natural emissions of matter and energy doing what they do. Following physical laws, creating patterns, evolving over time. We're part of these patterns. We're made of the same matter, governed by the same laws, connected to the same history. The atoms in our bodies were forged in stars, scattered by supernovas, gathered by gravity into planets, organized by chemistry into life, evolved over billions of years into forms capable of wondering about their origins. This is not a small thing. It's remarkable, profound, almost impossibly unlikely. And yet here we are. Whether we're alone or not, this story is worth telling, worth preserving, worth continuing. And if we're not alone, if others exist, they have their own stories, their own journeys, their own ways of being. And those stories are unfolding in their own time, at their own pace. Maybe we'll hear them someday. Maybe we won't. But the possibility remains, and that's enough to keep searching. The universe is patient. It doesn't rush. It doesn't demand. It simply is. And we are part of it. Tiny, brief, fragile, but capable of asking questions, of seeking answers, of wondering why. The silence is not an answer to those questions. It's the space in which we ask them, the context, the background. And maybe, in time, the silence will break. A signal will arrive. A pattern will emerge. A message will be decoded. And we'll know we're not alone. Or maybe the silence will continue, and we'll learn to accept it. To find meaning not in the answers we seek, but in the seeking itself. Both paths are valid. Both are worth walking. Because the journey matters as much as the destination. Maybe more. We're learning about the universe, about life, about intelligence, about ourselves. These lessons have value regardless of whether we find others. We're also creating something. Knowledge, technology, culture, ideas. Things that didn't exist before we started asking questions. Things that might outlast us. If another civilization ever finds evidence of humanity, they'll see these things. Our radio signals spreading outward at the speed of light. Our spacecraft drifting between stars. Our messages encoded on golden records. Our footprints on the moon. These are our attempts to reach across the void, to say we were here, we existed, we wondered, we tried. Even if no one ever receives these messages, they still matter, because they represent something important. The desire to connect, to communicate, to be known. This desire is part of being intelligent, of being aware, of recognizing that existence is shared, that we're not isolated, that others might be out there experiencing their own version of consciousness. The universe doesn't guarantee this connection. It doesn't promise that our messages will be received, or understood, or valued. But it allows for the possibility, and that's all we can ask for. The physics of the universe permit life, permit intelligence, permit communication. Whether these possibilities are realized often or rarely, we don't yet know. But we know they're realized at least once. Here, us. On this small planet orbiting an ordinary star in an unremarkable part of the galaxy. And if it happened once, it could happen again. Somewhere, sometime. In a way we might recognize, or in a way we never imagined. The silence doesn't rule this out. It just means the distance is large, or the timing is off, or the methods are different, or we're early, or we're late. or we're alone. All of these remain possible. And until we know which is true, we continue to search, continue to wonder, continue to listen to the quiet hum of the universe. The stars turn slowly overhead. The galaxies drift through space. Time passes in vast, unhurried waves. And somewhere in all of this, we exist. Asking questions, building instruments, reaching into the darkness. Not because we're certain we'll find anything, but because the act of reaching matters. The act of asking matters. The act of trying to understand matters. These acts define us. They're part of what makes us human, what makes us intelligent, what makes us aware that we're part of something larger. The universe doesn't have to answer us. It doesn't have to reveal its secrets. It doesn't have to make sense on our terms. But we can try to understand it anyway, on its terms, with patience, with humility, with openness to whatever we might find. And if we find silence, we can accept that. Not as defeat, not as loneliness, but as information. As one more piece of the puzzle. One more clue about how the universe works. Silence tells us that obviousness is not guaranteed, that visibility requires specific conditions, that communication across the cosmos is not simple. These are useful things to know. They shape our expectations, our strategies, our understanding of what's possible. They also remind us that rarity has value, that uniqueness, if that's what we are, is precious, that life, consciousness, intelligence, these are not mundane. They're remarkable, worth protecting, worth celebrating. And if we're not unique, if others exist, then we're part of a community. Not a community that communicates easily, not a community that shares daily life, but a community nonetheless, connected by the fact of existence, by the shared experience of emerging from matter into awareness. This is a profound connection, even if we never speak, even if we never meet. The simple fact that others exist, that they wonder as we wonder, that they look at their sky and ask the same questions, this creates a bond across time, across space, across forms we can barely imagine, but a bond nonetheless. The silence doesn't break this bond, it just makes it quiet, subtle, something we feel more than hear. And maybe that's appropriate. Maybe the universe is teaching us that connection doesn't always mean conversation, that presence doesn't always mean visibility, that knowing we're not alone doesn't require constant communication. Maybe it's enough to know that somewhere, in the vastness of space, in the depth of time, others might exist, living their lives, solving their problems, creating their cultures, looking up at their sky and wondering. This knowing is speculative, it's not confirmed, but it's reasonable, based on what we understand about the universe, about life, about the laws of physics and chemistry, about how complexity emerges from simplicity. We have no reason to think Earth is special, no evidence that the processes that created life here can't happen elsewhere. No proof that intelligence is unique to humans, which means life is probably common. Intelligence might be rare, but not impossible. And somewhere, in all those billions of stars, someone else might be listening to the silence and wondering the same things we wonder. This thought is comforting, not in a way that solves anything, but in a way that places us in context, that reminds us we're part of something ongoing, something vast, something still unfolding. The universe is not finished. It's still evolving. Stars are still forming. Planets are still cooling. Life is still emerging. Intelligence is still developing. We're witnessing a moment in this process, not the end, not even the middle, just a moment. One frame in a film that will run for trillions of years. In that context, our questions about silence make sense. We're asking them early, before the full story has played out, before all the evidence is in. The answers will come. Maybe not in our time, maybe not in any human time, but they'll come. The universe will continue to reveal itself, slowly, gradually, in ways we can't predict. And future beings, whether human or something else, will have more data than we do, better tools, deeper understanding. They'll ask questions we haven't thought of, see patterns we can't recognize, know things we can only guess at. This is how knowledge grows, across generations, across time. Each iteration building on what came before, each question leading to new questions, each answer revealing new mysteries. We're part of this process, one link in a chain that extends backward to the first humans who looked at the stars, and forward to beings we can't imagine. Our contribution is the searching, the trying, the refusing to accept that some questions are unanswerable. Even if we never find answers, we're creating the foundation for those who come after. We're developing the tools, the methods, the frameworks of understanding. We're also keeping the questions alive, making sure they don't get forgotten, making sure that wonder doesn't fade, that curiosity doesn't die. This is important work, even if it feels futile sometimes, even if the silence persists, even if the universe seems indifferent to our efforts. Because the universe isn't indifferent. It's just operating on a different scale, a different timeline, in ways that don't always align with human needs or expectations. But it's there, real, vast, full of structure and pattern and process, full of possibilities we're only beginning to explore. And we're part of it, not separate, not outside, not observers standing apart, but participants, made of the same stuff, following the same rules, part of the same story. The silence is part of that story, not the end of it, not a failure of it, just a chapter, one phase in a longer narrative. And chapters end, phases change. What's silent today might be loud tomorrow. What's hidden today might be visible tomorrow. What's unknown today might be understood tomorrow, or it might not. The universe doesn't guarantee progress, doesn't promise revelation, doesn't owe us anything, but it permits exploration. It allows for understanding. It makes curiosity possible. And that's enough. We can work with that. We can build on that. We can continue to ask questions, continue to search, continue to listen. Not because we're certain of success, but because the alternative, giving up, accepting that some things can't be known, feels wrong, feels premature, feels like abandoning something important. So we continue, quietly, patiently, with the understanding that this is a long project, a multi-generational effort, something that won't be resolved quickly. And in the meantime, we learn, we grow, we develop, we create, we share what we find. We teach the next generation, we pass on the wonder. This is what civilizations do. They carry questions forward, they preserve knowledge, they maintain traditions of inquiry. They ensure that important work continues even when progress is slow. The search for life beyond Earth is one of these traditions, one of these questions that transcends individual lives, that matters to everyone. that shapes how we see ourselves and our place in the universe. And the silence, rather than discouraging this search, makes it more important. Because silence is not an answer. It's an absence of answers. And absences demand investigation. Why the absence? What causes it? What does it tell us about the universe, about life, about ourselves? These are the questions we're really asking when we ask about silence. And they're deep questions, fundamental questions, questions that touch on physics, biology, philosophy, psychology, sociology, and more. They're questions without simple answers, without quick solutions. They require us to think broadly, to consider multiple perspectives, to hold contradictory ideas in mind simultaneously. This is uncomfortable. Humans like certainty. We like to know, to be sure, to have clear answers we can rely on. But the universe doesn't always provide these. Sometimes it offers ambiguity, uncertainty, multiple possibilities that can't be resolved without more information. Learning to sit with this uncertainty is part of the process, part of what it means to search for truth, to pursue understanding, to engage with reality on its own terms, rather than on terms we prefer. The silence of the universe is one of these uncertainties. We don't know why it exists. We have theories, guesses, ideas, but we don't know. And that's okay. Not knowing is a valid state, a necessary state, the beginning of understanding rather than the end of it. We start with not knowing. We observe. We gather data. We form hypotheses. We test them. We refine them. We learn. And slowly, over time, not knowing becomes knowing. Mystery becomes understanding. Questions become answers. But this process takes time, and patience, and willingness to accept that some questions won't be answered in our lifetimes. The silence might be one of these, a question we carry, a mystery we pass on, a puzzle for future generations to solve. Or maybe not. Maybe the answer comes sooner. Maybe a signal arrives next year, or next decade. Maybe our instruments improve enough to detect something we've been missing. Maybe our understanding deepens enough to recognize patterns we couldn't see before. Both are possible. Both remain open. And until one or the other happens, we continue as we have been. Searching, listening, wondering. The stars remain distant. The galaxies continue their slow drift. Time passes. And in this vast, quiet universe, we exist. Small, brief, curious, aware. Aware of the silence. Aware of the questions. Aware of the mystery. And willing to sit with all of it. To hold it gently. To let it be what it is without forcing answers that aren't ready to emerge. This is a kind of peace, not the peace of resolution, but the peace of acceptance, of being okay with not knowing, of trusting that understanding will come when it comes. And if it doesn't, that's okay too. Because the value isn't only in the answers, it's in the asking, in the caring enough to ask, in the believing that questions matter, that understanding matters. That truth, whatever it is worth pursuing. This belief sustains us, through long nights of observation, through years of negative results, through decades of silence. It reminds us why we started, why we continue, why it matters. And maybe that's the real answer to why the universe seems silent. Not that it's hiding, not that it's empty, but that listening takes time. Understanding takes time. Connection takes time. Time on a scale that makes human lifetimes feel like heartbeats. Brief, rapid, over before the universe has had time to respond. But heartbeats matter. Each one is real. Each one is part of being alive. And collectively, across generations, they add up to something larger. Something that persists. Something that might eventually hear an answer. Until then, we listen. We wait. We continue. In the silence. In the vastness. In the quiet hope that we're not alone. That others exist. That the universe, in its own time, will reveal itself. And if it doesn't, if the silence continues forever, we'll have learned something important. About scale, about distance, about time, about rarity, about ourselves. We'll have learned that existence doesn't require an audience, that significance doesn't depend on being known, that life, consciousness, intelligence, these are valuable in themselves, not because someone else acknowledges them, but because they are. This is a profound lesson, one the universe might be teaching us through its silence. That meaning is intrinsic. That we matter because we exist. Not because we're special. Not because we're unique. Just because we are. And in being, we participate. We contribute. We add our small voice to the ongoing story of the universe. Quiet as it might be, brief as it might be, it's real. It's here. It counts. The silence doesn't diminish this. It frames it, gives it context, reminds us that we're part of something vast, something ancient, something still unfolding. And in that vastness, in that antiquity, in that ongoing unfoldment, we find our place. Not at the center, not alone, but present, aware, asking questions into the dark, listening for answers that may never come. And somehow, in the listening itself, in the patience, in the wonder, finding something like peace. Good night.